Hey, student, how are you? Welcome to our session on the Introduction to Probability. Let's take a look. Probability is the measure of how likely an event is to occur. From 0% chance, never going to happen. For example, rolling a 7 on a fair six-sided die is never going to happen. To a 50% chance, might happen. To a 100% chance, definitely going to happen. A sample space is all possible outcomes. All possible outcomes. An event is a subset of outcomes. For example, rolling an even number is a subset of all the possible outcomes of rolling a fair six-sided die. The probability of an event occurring is equal to the number of favorable outcomes divided by the total number of possible outcomes. Let's take a look at an example. Find the probability of picking a red marble from this bag of marbles. We need the number of red marbles divided by the total number of marbles in the bag. We have 3 red marbles out of a total of 10 marbles. A 30% chance of this event occurring. Theoretical probability is what we expect to happen. Rolling a 2 on a fair-sided die. We have one face of the cube, that is a 2, out of 6 total possible outcomes. About a 17% chance of rolling a 2. Experimental probability is what actually happens when we do trials. If you roll a die 100 times and get a 2 19 times, our experimental probability is 19 out of 100. 19% of the time we rolled a 2. Theoretical probability is what we expect. Experimental probability is what actually happened when we did trials. The law of large numbers says that experimental probability approaches theoretical probability the more trials we do. If we flip a coin and get a head, our experimental probability is 100%, one head out of one toss. We flip a coin a second time and get another head, our experimental probability is still 100%. We flip a coin a third time and get a tail. Now we have 2 heads out of 3 tosses. That is a 67% experimental probability. If we continue to do many trials, we see that the experimental probability approaches the theoretical probability of 50%. I recommend doing that activity. It's pretty fun. Multiplying probabilities. The probability of A and B depends on independent events versus dependent events. Let's take a look. Independent events. When one event does not affect the likelihood of the other event occurring. Probability of rolling a 2 and rolling a 5. Probability of flipping a coin and getting a head, flipping it again, and getting a second head. Or picking marbles out of a bag, replacing them, and then picking a second marble. These are all independent events. The first event does not affect the probability of the second event occurring. Let's take a look at an example. What is the probability of picking a red marble, replacing it, and then picking a second red marble? Probability of red and red. And we'll multiply the probabilities together. We have 3 red marbles out of a total of 10. We replace the red marble, so we still have 3 red marbles out of a total of 10. Multiply fractions straight across top and bottom, and that is 9% chance of picking red and red. Dependent events. When the outcome of the first event affects the likelihood of the second event occurring. For example, picking marbles out of a bag without replacing them. Let's take a look at an example. What is the probability of picking a red marble, not replacing it, and then picking a second red marble? Probability of red and red. We will still multiply the probabilities together, and we still start with 3 red marbles out of a total of 10. However, after we pick the red marble, there are only 2 red marbles left in a bag of 9 marbles. We did not replace the red marble that we picked. We'll multiply fractions straight across and reduce, and we get about 7%. A lesson quiz. You can always pause the video here and try these before we go through them. All right, here we go. What is the probability of picking a heart card from a standard deck of cards? Probability of heart. There are 52 total cards in a standard deck, and there are 4 suits: clubs, diamonds, hearts, and spades. So 52 divided by 4, there are 13 heart cards. So probability of picking a heart card, number of heart cards out of the total number of cards in the deck, 13 out of 52, or 1/4, a 25% chance. Number 2. There are 5 girls and 8 boys in a class. What is the probability of picking a girl? Probability of picking a girl is equal to the number of girls divided by the total number of students. We have 5 girls out of a total of 13 students. A 38% chance of picking a girl. Number 3. What is the probability of rolling doubles on a pair of dice? Well, we need the number of ways we could roll doubles. We could do a 1 and a 1, a 2 and a 2, 3 and a 3, 4 and a 4. There are 6 ways to roll doubles out of a total of 36 possible outcomes. So 6 ways to roll doubles out of a total of 36 possible outcomes. That's about a 17% chance of rolling doubles. Number 4. What is the probability of flipping a coin, getting a head, rolling a die, and getting a 3? Probability of heads and 3. Well, these events are independent. One event, flipping a coin, does not affect the outcome of rolling a number on a die. So the probability of flipping a coin and getting a heads is 1/2. Probability of rolling a 3 is 1 out of 6. We'll multiply the probabilities together, heads and 3. And we'll multiply fractions straight across top and bottom. We get an 8% chance. And the last one, number 5. Using the information in problem number 2, what is the probability of picking a girl, not replacing her, and then picking a second girl? Probability of girl and girl when these events are not independent. So we'll take a look. Probability of girl and girl, we're multiplying probabilities, and multiply. Probability of a girl, we have 5 girls out of 13 total students. We pick that girl and don't replace her, so now we have 4 girls left out of 12 total students. We'll multiply fractions straight across, top and bottom, reduce, and there's a 13% chance of that occurring. Up next, we'll be adding probabilities, taking a look at mutually exclusive or non-mutually exclusive events. And that concludes our introduction to probability. Thanks so much for joining this session, and I'll see you next time.